I have reached the point where I will be able to solve the problem. So this is a simple problem which I have solved, and I would like to explain it. Suppose this uniformly distributed load is all over the span to beam. First, the load is acting UDL of W kilonewton per meter. Total load is WL. This is my A, B, and C. This C I have put up for the calculation of. I'll put it later on. For now, this is our question. So first step we need to do is find the reaction VA and VB from the equilibrium equation. Fx equals to 0, Fy is equals to W VA minus W kilonewton into, this is my kilonewton, I'll convert it into point load. So for that, multiply with L plus VB. This VB equals to, so VA plus VB is equals to W into L kilonewton. Now the summation of moment about A equals to 0, VA into 0 plus W into L into, it is acting on L by 2 minus VB into L equals to 0. Now from here, if we solve, then from WL by W squared by 2 minus VB into L, 1L and 1L get cancelled, so we're left with VB equals to minus WL by 2 kilonewton. So now we'll substitute this VB value to this equation 1, and from there we'll get VA equals to WL by 2. Okay, and after that, after the calculation of the reaction, what we'll do it, we'll in order to draw the shear force and bending moment diagram, we will calculate the shear force and bending moment. First we will start with the shear force diagram. In the shear force diagram, the upward force will be taken as positive and the downward force will be taken as negative. Shear force at A is going to be my C. VA is WL by 2. It's going to be my WL by 2. So here we have written WL by 2. Shear force at A to B. Shear force at A to B, how much it's going to be? WL divided by 2 and minus W into L, isn't it? W into L. So from here, it will be WL by 2, and shear force at B is WL by 2, and we already have minus WL by 2. So this won't get cancelled, and shear force at B is equals to B is going to be 0. Now the moment calculation, for the clockwise, we will take it as a positive, and for anti-clockwise, we will take it as a negative. We know that moment equals to force into perpendicular distance. Bending moment at A is going to be 0 because there's no distance. So, and for bending moment at B is going to be WL divided by 2, and it's acting in a full span, WL divided by 2 into its full span, minus, for this, it's WL into L by 2. So it's going to look like this, WL by 2 into L get cancelled, and now we will introduce one point here, C point. Now we'll calculate the bending moment at C, how much it's going to be. So we can see that from here to here, first WL divided by 2 into, it is acting in L by 2, WL divided by 2 into L by 2, and anti-clockwise. Because of this, it will rotate in anti-clockwise direction, and because of this, it will rotate in a clockwise direction. So this is going to be my positive, and this is going to be my negative. So it's going to be W into L by 2, W into L by 2, because now if this is my full length from here to here, it's going to be L by 2, and half of L by 2 is L by 4. So BM, bending moment at C, is WL by 2 into L by 2 minus WL by 2 into L by 4 is equals to WL squared by 8 kilonewton per meter. So by saying this, we are going to draw, we will draw this. First is shear force diagram. From A is how much? You can see the WL squared, WL by 2, positive WL by 2, and then BM, bending moment, shear force at B is 0. Shear force at B is equals to 0. Shear force at A to B is WL by 2. It is going to be minus WL by 2. So it's going to be my linearly varying load from positive to negative, 1 degree curve. So at bending moment at B is my 0, so we will join it simply. So, and from here to here, its length is x, and from here to here, we'll consider it L minus x. Okay, L minus x. By similar triangle properties, this is my WL by 2 into x equals to WL by 2 with the minus L minus x. So from here, x is going to be my L by 2. For this distance, L by 2. Without even calculating, you can assume it if in this simple problem. Now we're done with the shear force diagram. Now we'll come to the bending moment diagram. It's here, bending moment at A is 0, bending moment at A is 0, bending moment at C is W squared by 8, okay, bending moment at C is what? 0, bending moment at B is 0. It is going to be my parabolic curve, 2-degree curve. And here, for this such simple problem, you do not have to check for the slope, but in case of but in order to solve the complex problem, you'll have to understanding of this slope. We know that shear force is equals to slope dm by dx is equals to v, and if my bending moment dm by dx is equals to 0, then our shear force is also equals to 0. We know this relationship, and we can also go with this diagram, but we have opted for this diagram. This is the correct diagram, but why we have chosen this instead of this, now I'm going to see. Now I'm going to explain it. Here you can see that theta is equals to 0. Therefore my dm by dx is also going to be 0. Therefore my shear force is also going to be 0. Here the theta c is not equals to 0. Similarly for dm by dx is not equals to 0. Bc is not equal to 0. For theta b is equals to 0. dm by dx is also going to be 0. So now you need to compare this with this. Do you see that here it is said that theta at a is equals to 0, whereas here the theta at a is not equals to 0. So similarly for this, theta at c is not equals to 0, but here the theta at c is equals to 0. Theta at b is equals to 0, but here the theta at b is equals to not 0. So that's why we'll not consider this diagram, but we'll consider this. Now you can merge this with this actual diagram, and you can see that the theta a is not equals to 0. Yeah, theta a is not equals to 0, and therefore the dm by dx is not equals to 0. dm by dx is not equals to 0, and here at the point c, when we draw a tangent, it's going to be a 0. Here's no slope is forming. Theta c is equals to 0. Here you can see that bending shear force at c is equals to 0. So here you can see that shear force at c is also equals to 0, and for this theta b is not equals to 0, dm by dx is not equals to 0, shear force is not equals to 0. That's why we opt for this bending moment diagram, not this bending moment diagram. Ito na for today.